Hello learners, welcome to the yet another session of MEV 002 course, that is Environmental and Occupational Hazards. Today we are going to discuss about mitigation of chemical hazards. Learner, in the previous session we have learnt about different types of chemical hazards and their adverse health impacts. In this session we will learn about their controlling, or otherwise we can say that mitigation measures. So first of all, we have to see that before going to the mitigation measures, one has to check the assessment criteria. So hazard assessment, indicators of toxicity hazards like LD50 or LC50, or otherwise a wide range of in vitro and in vivo techniques for assessment of skin and eye irritation, or otherwise skin sensitization, mutagenicity, acute and chronic dermal and inhalation toxicity, reproductive toxicology, carcinogenicity, like that. So the LD50 is the statistically derived single dosage of a substance that can be expected to cause death in 50% of the sample population. It is therefore an indicator of acute toxicity. It is usually determined by the ingestion using rats or mice, even though other animals may be used sometimes. So LD50 is also determined by other routes like by skin absorption in rabbits. So the values are affected by species, sex, age, like that. So the LC50 is the lethal concentration of a chemical agent. For example, in air or water, whatever it is the particle, chemical particle which can have or potential to exert an adverse effect. So that will cause the death of 50% of the sample population. So this is most appropriate as an indicator of the acute toxicity of chemicals in air, that is breathed, or otherwise in water for aquatic organisms. So first we have to see that what exactly the flammable chemical materials are there. Certain chemicals, they definitely have the fire as well as explosion risks because they ignite easily, and also their vapors frequently travel a considerable distance to an ignition source remote from the point of chemical escape. Considerable heat is generated in this process. So many volatile substances which liberate heat at the rate, sometimes it may be 10 times faster than the burning wood. So the fire that spreads easily like a running liquid fire, or otherwise it is a pool fire or a fireball. So heat radiation or thermal lift, that is normally we can call it as a convection. So along with this, explosion will happen. That means it is a confined vapor cloud explosion, that is CVCE, that can be resulted from the ignition of vapor within a building or within the equipment area. And also a boiling liquid expanding vapor explosion, that can also be resulted when invented containers, or we can say that unvented containers of flammable chemical burst with the explosive as well as violence as a result of the buildup of the internal pressure. So unconfined vapor, that is a cloud explosion, that can also be resulted from the ignition of a very large vapor or otherwise gas or a chemical cloud. So clearly flammable chemicals, they will definitely pose a health risk if the substance or its thermal degradation or combustion products are toxic in nature, like carbon monoxide, or otherwise result in oxygen deficiency because oxygen is consumed. Hot smoke and also other respiratory irritants like aldehydes, they are definitely produced in this process. Normally, flame propagation requires fuel, gas, or otherwise vapor. That means, or a combustible dust. That means to get a flame, these things have to be there. So within certain concentration limits. And the second is oxygen supply. Generally from the air, definitely it will be available. This oxygen supply also above a certain minimum concentrations. And the third criteria is ignition source of minimum temperature, energy, and then the duration of that ignition source. So all these three, they are represented by the three corners of the triangle. They are generally present to any substances that can catch fire. But no ignition source is required if a material is above a specific temperature, and also no additional oxygen is required if an oxidizing agent is present, or sometimes in few cases when oxygen is within the fuel molecule, like ethylene oxide as an example. So, the flammable chemical handling or the storing or transporting and all these three things and using without any safety procedures that resulted in the hazards like fire and also explosion that leads to health effects and sometimes death may occur. So, these can be eliminated or we can reduce by stringent safety procedures. So, how to control these chemical hazards? So, we will see some of the controlling measures like some strategies for the handling the flammable material to minimize at the design stage itself. So, the risk of fire explosion, like by substitution with a less volatile chemical or operation at low temperatures, and sometimes we can also say that avoidance of air ingress or otherwise use of inerting. That means we have to switch off the fire, that is the otherwise we have to use the inert material, and designed to minimize leakages and also avoidance of potential ignition sources, and also the to minimize the risk of appropriate systems of the work. Sometimes we can also mitigate the effects of fire or explosion by the detection of detection provision, spacing, appropriate construction materials, shielding, venting, sometimes it is an extinguishment division, and also the evacuation of the personnels. Fire prevention for this type of flammable material is present. Theoretically, if one corner of the fire triangle is eliminated, a fire or explosion is highly impossible. But in practice, if flammable gases or vapors are mixed with air in flammable concentrations, sooner or later the mixture is likely to catch fire or explode because of the difficulty of eliminating every source of ignition. For reliable control of flammable materials like a combustible dust, the aim is to remove two corners from the fire triangle. So, like this, some combinations of prevention of a mixture forming within the flammable range, sometimes it may be elimination of the ignition sources like this. For example, if you will see the dust explosions, the avoidance and mitigation effects of the dust explosion definitely involves some combination of the elimination of ignition sources, which is inherently very difficult to ensure, and then atmosphere control, like controlling dust concentrations or inerting that dust, and the containment of explosion or otherwise we can say that over pressure, that is by designing plant which is capable of withstanding in excess of the maximum explosion, over pressure, or sometimes it may be a safe venting of the forces through blow of panels, doors or membranes, and limiting the inventory also. So, the restriction of spread by means of these chokers or otherwise by the advanced inerting. Use of water sprays, it is also one of the important mitigation measures, or otherwise we can also use that very rapid injection of the suppressant gas or powder. And also good housekeeping also very much required, particularly to avoid a devastating secondary explosion which is followed by the redispersion of any accumulation of the combustible dust. A similar logic is also applicable to the control of the explosion, which is involves the gas or vapor, but other measurements are also there, like dispersion by steam or containment of the water curtains. They are also applicable to vapor clouds in the open air. So, containment or otherwise we can say that it is a diversion of a blast, normally by the blast valves, and reducing its effects by the appropriate spacing of the equipment. buildings where they are also applicable. Then another example I would like to give is pyrophorics. These pyrophorics, whenever they are using the control measures to reduce the risk from the handling pyrophorics are storage and also the handling the quantity, that is the minimum quantities are necessary at particular time. Now we will see that how to control the fire. So before seeing or before learning about the mitigation measures of fire, first we have to see that how many types of fires are there. So first we have to see that the type A fire, that means it involves solid materials, generally organic materials, in which combustion normally takes place with the formation of glowing embers. Type B fire is also there, that involves a liquid or liquefiable solid. That means the miscibility, or otherwise we can say that with the water is an important characteristic feature for this one. Type C fire is also there, it involving a gas. Type D fire involving a burning material, or suppose it is a metal, for example magnesium is there, aluminium, sodium, calcium or zirconium. So fire detection and suppression forms the basis of the fire control, with emergency backup procedures also to mitigate the consequences. Now we will see that what type of fire extinguishing materials are there. So the penetration and cooling action of water, that is highly required with class A fires, like those involving paper, wood, textiles, refuse, and water is applied in the form of a jet or spray, or sometimes it may be a foam, or multi-purpose powder extinguishers are also other alternatives. Extinguishment of class B fire can be achieved by the smoothing action of the dry chemical like carbon dioxide or foam. So most flammable liquids, they will float on water because of the differences in the specific gravity, so that the water as a jet is unsuitable. A mist instead of water, a mist may however be effective. And water is also widely used to protect equipment that are exposed to heat. Dry powders are also there, they are also effective on flammable liquid or electrical wires whenever they caught fire. Foam is a proportioned mixture of water and foam concentrated aspirated with air to cause expansion. That means from 6 to 10 times the volume, that means the low expansion foam. If it is, suppose it is up to 100 times, there is a high expansion foam. So it transports water to the surface of the flammable liquid and also enables it to float and extinguish the fire. An effective system of this fire extinguishers are mainly depends upon the type of flammable liquids, that means that determines the type of foam. For example, standard or alcohol resistant grade, they will be used, and aqueous film forming foam that may be used for rapid knockdown, and carbon dioxide is also useful wherever there is a minimum damage should be caused to the materials at risk on fires, like in liquids or solids or electrical fires, but not wherever there is a high risk of reignition. So it is likely to be ineffective outdoors due to the rapid dispersion is there because of the air movement. So it is unsuitable for the reactive metals, sometimes or otherwise it is a metal hydrides or materials with their own oxygen supply like cellulose nitrate. Dry powders are also there, they are also effective on flammable liquid or electrical fires. Special powders are available for the use on metals, that is dry powder extinguishers may be used in class C fires like gases and liquefied gases in the foam in the form of a liquid spillage or a liquid or gas leak. So this must be accompanied by other actions also, that is stopping the leak, and this is necessary to avoid accumulation of unburned flammable gas air mixture that could be subsequently resulted in the explosion. So activation may be an automatic by a detection of a system or a manual sometimes, and vaporizing liquid halogen agents are also electrically non-conductive in nature, and they are very effective on wider range of the combustibles, particularly flammable liquids and also electrical wires. A lock-off system, that is also there. It is highly required on fixed installations to protect the personnel, or otherwise the normal extinguishing concentration that will be used 5% by the volume. To reduce the hazards, first thing is modify in the process, that is significantly minimize the areas of liquid explosion. And the second point we have to remember is low flash liquids that should be substituted by non-flammable or less flammable material. And also use of exhaust systems for the removal of residual vapors. And the next one is minimum quantities of the chemicals should be used. And also ensure that there should not be any ignition sources at the storage area of flammable liquids. And also liquid chemicals that receives and dispensing containers should connect properly with the electrical conductor to avoid sparks from the static charges that are produced at the time of pouring. And also another factor that is an accumulation of vapors should be prevented by safe handling procedures like sufficient ventilation. And standard labeling should be most important, used for the flammable liquid containers like dangerous flammable liquids. So we have to paste it like that, or otherwise we have to paint on that one, that is a proper labeling is required. Restricted to heat, sparks and open flames, and close the containers when not in use like this. And also containers which provided by the manufacturers should be used to store flammable liquids, and also should indicate the hazards by proper labeling. Now we will come to the corrosive chemical material. That means we have seen that what is the procedure of the corrosion, and some chemicals which give strong acid reactions frequently on interaction with water like mineral acids. Some organic acids that can also be very corrosive in nature. Phenolics that can be resulted in local anesthesia so that the pain will be absent for some time, for temporary, that is a contact may go unheeded. And halogen compounds are also there, acid anhydrides or acid halides. They will react with water to form their parent acids. So common bases are also there, which they will have these aqueous solutions alkaline. Certain oxidizing or the reducing compounds and salts of which in the form of solid, that is a bulk or the dust, or as a solution, that can also be produced by the irritation by the thermal burns. So strong acids and alkalis, they will produce effects within a moment. That is for example, if you will see that sulfuric acid and nitric acid, they will quickly become hydrated by the water content of the skin or mucous membrane and combine with the skin protein to form the albuminates. So sometimes with charring also happens. So some chemicals are asphyxiants. So asphyxiants, what they will do, they will interfere with the body's oxygen uptake mechanism. Air normally contains 21% of oxygen. So oxygen deficiency in inhaled air because of the presence of the nitrogen or argon or carbon dioxide in a confined space. That means it is depending on the concentration and the duration of the exposure that may affect the body and ultimately cause death from the simple anoxia. And corrosive chemical materials should be handled by the procedures like a correct choice of material of construction by physical means like paints or metallic porcelains, plastic or enamel lining or the coatings, or by the chemical means like alloying or coating. Some metals like aluminium, they are rendered very passive by the formation of an inert protective film. Some alternatives are also there, like a metal to be protected that may be linked to electrically to a more easily corroded metal like magnesium to serve as a sacrificial anode. The attacking process is accelerated by an increase in temperature and also other measures like segregation that should be done for all chemicals like acids, bases and organic compounds and inorganic substances. Personal protective measures like wearing a laboratory coat, gloves and chemical splash goggles are also there while working with these hazardous chemicals. And also dilution procedures are there. So careful addition of the acid to the water, not the water to the acid, should be ensured. And some inorganic chemicals like sodium hydroxide are very slippery in nature, and this type of corrosives we have to clean immediately if any spills or leaks or splashes or dribbles are observed. Working with volatile irritant chemicals like ammonium hydroxide has to be used, only fuming cupboard should be used for the dilution purposes. Eye wash stations and shower stations should be arranged within the 55 feet of the corrosive work area. So we have to ensure that, and also to ensure packing of acid containers for the leakage or the damage, and we have to follow the proper disposable procedures for the emptying the containers, and wash up the chemicals in case of chemical spills on body by flooding with the huge amounts of water immediately to avoid the severity of the burn. Now we will see that reactive materials of the chemicals. So reactive chemicals are very sensitive towards friction, shock, air, water, light, heat, or simply we can say that with other chemicals also they are very reactive. So some reactive chemicals are highly unstable in nature and immediately decompose by releasing energy on their own. So some reactive chemicals they will release sometimes toxic gases while reacting also, and some may give the explosive chemical decomposes or otherwise ignite rapidly in the presence of a shock or combustion. So some of the mitigation measures for this type of reactive metals or reactive chemical materials, we have to use the guidelines when handling and strong reactive and explosion chemicals, like to familiarize the employees with handling and storage techniques, and to follow the plan of action which is established by the individual companies, and also to recognize the cause of reaction and also isolate the chemicals from the site immediately. And reactive chemicals should be stored in cool and dry areas, because they have to be kept away from the sunlight and also source of heat. And most important thing is to conduct the workshops on usage of emergency equipment, storage of the quantities which are potentially explosive materials in store. Their use should be strictly limited. That means the procedures have to be given to the employees before using these chemicals. And also the stores should be especially designed and also constructed for the non-combustible materials, and also located away from the other hazards like brick, coal, bunkers, which are useful for the small samples, but also purpose built constructions with explosion proof lights like this, and also required for the larger quantities. They should be designated no smoking areas, have to be well labeled, and also stores that have to be used exclusively for these materials, and other combustible materials like fabric, paper, organic solvents should not be stored there. So generally the substances in this type are unstable when heated or exposed to light. They should be stored under cool and or otherwise in the dark. However, sometimes liquids with added stabilizers, the cooling may cause a separation of material from the stabilizer. So precipitation is also one of the important factor, and potentially explosive compound from a dilution that may occur on cooling. So in both cases this can be represented a hazardous situation. So stores should be ventilated properly and also ventilated for the sound, that is no cracks in floors, no rusty window frames, no water seepages like this. Stores should be clean and then tidy, and also should be locked properly. So the contamination must be avoided and high standard of housekeeping should be maintained. Heat sources should not be permitted nearby, and materials should be purchased in several small containers rather than the one large container, and also always it is stored in original containers only, and also the integrity of the labels should be checked, and also the use must be restricted to the experienced workers only, and awareness of the hazards and the necessary precautions have to be maintained properly, and the records of usage should be kept, and stock should be maintained, and also it should be on rotation, and old materials should be disposed of compulsory to prevent the glass fragments from the flying in the event of an explosion, and also there should be metal gauzes to screen the reaction flask like that, or otherwise it should be kept in the cages. For example, for the desiccators or the vessels of awkward size, shape may be covered with a cling film or the transparent film. And safety features in the chemical engineering operations like inventory and then reduce inventory of chemicals, and continuous operations may be preferable to batch, and low residence time, that is a contacting equipment may be better than the cheaper alternatives. And monitoring the temperature and pressure flow, composition, freedom from the contamination and other appropriate properties of all streams wherever it is relevant. And also we have to consider the automatic control isolation that will provide for the isolation from the upstream and downstream operations, and also to consider the provision of automatic and remotely operated isolation techniques. And also for the cleaning requires the contaminants that provides and also that provides measures to remove unacceptable contaminants from the feed materials or the process streams, and also services like entrained liquids or the tramp metals, unwanted particulate solids. Pressure or the temperature operate at moderate temperatures, and also moderate pressure wherever there is a possibility. And also avoid superheated liquids that will flash off, and also if it is practicable allow for effects of over or otherwise under temperature and then pressures also. And assessment by hazard and operability study, that is normally we can call it as a HAZOP, that is a continuous flow with continuous flow operations by using a proper HAZOP procedures. So this type of mitigation measures we have to observe in the chemical hazards. So dear learner, I have to conclude this here, because every industrial worker may expose to various types of physical hazards like heat, cold, noise, vibration and radiation, and also like the chemical hazards like flammable, corrosive and reactive chemicals. So all these chemicals are prone to have adverse health effects on the human beings, and also if we want to take appropriate measures, then the adverse effect is very high. So the mitigation measures varies in different occupations, from the medical measures or engineering measures and also the administrative measures to the legislations. So these are the important chemical hazard mitigation measures, so we have to follow. So we have to conclude over here, and then in the next session we will come up with the other important aspect of the environmental and occupational hazards. Thank you.